Good morning, good afternoon, and welcome you all to this conversation on the densification of the RAN and its evolution. This is part of a report by Sensafili in collaboration with RCR Wireless. I'm Monica Paolini, and today with me I have Jim DeKoekkoek, who is the product line manager for antennas and small cells at Kathrein. Jim, thanks for being with us today.
Hey, thank you, Monica. It's a pleasure to be here and glad to share some things.
Excellent, and I look forward to it as well. Maybe we can start with you telling us what is that you personally do at Kathrein, and what is the Kathrein doing in the in this area of in the area of densification.
Good questions. My role here is one of being really the interface between our engineering department and the market. And as part of that, it really is a good chance for me to visit with customers, find out what their needs are, where they're going, what the directions are, and coordinate that with our engineering folks, which are largely based in Rosenheim, Germany.
And what about Kathrein?
Oh, Kathrein USA. Big changes in the last couple of years here. We recognize that, this is a competitive business, that Kathrein really needs to become a player in the US more than they have been, and we've made major strides that way. Relocated our office to Richardson, Texas, which is more of a tech center, closed a manufacturing plant in Oregon, opened a huge new facility in Mexico, have done a lot of marketing and lots of emphasis to really increase our presence in the U.S.
Mm-hmm. And because originally still it's a company that's based in Germany and with clients worldwide.
Exactly, and one of our challenges has been in the past was we were more Eurocentric than we really wanted to be. And we recognize that the U.S. is a strong market for us. We have good opportunities here. We have great products. The Kathrein name means a lot to people. The quality is excellent. It's an enjoyable company to work for those reasons.
Mm-hmm. Right, and we're going to talk about it later because the U.S. and Europe and the rest of the world we're using the same technology, but oftentimes in very different ways. So that's interesting that you are able to see all of that. Now, when we talk about densification, there are clearly many ways to go about it, and operators are pursuing different paths at the same time. But when I think about Kathrein, the thing that comes to mind more recently now is the Street Connect project you're done. This is really a novel approach to densification. Can you tell us a little bit about that?
Yes, Street Connect has actually been a lot of fun for us. We were contacted originally by an operator in Switzerland by the name of Swisscom. They had done quite a bit of evaluation of costs related to deploying small cells. They had the typical problem where the data usage is going sky high. I think they said that since 2008, it had gone up 100 times. They have very strict zoning standards, and so to deploy systems in their cities is difficult. And so they were looking, where can we install antennas for small cells in new and novel places? And they actually came up with the concept of installing it in the ground in what looked like manhole covers. And they started doing some trials. Actually first contacted Kathrein. We did some development, some joint development, started doing some trials to figure out what the real performance of this could be, what the coverage areas are. And voila, we have this product now. It really is turning out to be a great product for us, not only in Europe, but also here in the U.S.
Mm-hmm. And no, you said that they look like manholes, but they're not. What's the difference?
To the average person walking by, they can't tell the difference. The cover, of course, is not metal like a normal manhole cover. but it is a kind of a metal-looking plastic cover. It's designed for heavy trucks and traffic, so it in terms of load bearing and so on, it handles that just fine. And again, to the average person walking by, they don't have a clue.
What if you were to put them in a manhole itself? Because obviously you'd have probably have propagation issues with the metal of the cover itself, right? But does it have to be on a different area?
It does need to be in a different, its own separate enclosure. We don't want to restrict access to an actual cover where there actually might be a need for workers to go into that. And also it's smaller in diameter. So it's about 17 and a half inches in diameter, which actually is really too small for most people to get into.
That's really interesting. So usually what we do when you go from macro to small cells, you go from way up high and you get progressively closer to the subscriber. Now you go one step further because you go below the subscriber, right? What does that do in terms of the interference, say, with the macro when you have a co-channel deployment where the macro and the small cell use the same spectrum?
Yeah, good question. I mean, placement is really key there to try to prevent that interference. And so if you're designing a system, you're going to look at maybe trying to shield from the macro cell by a building. Part of the coverage of this system really depends on reflection. So it's commonly located adjacent to buildings where we actually get good multipath and good coverage that way.
Mm-hmm. Right. Now, in terms of the sort of the business model and the cost. So let me first ask you about the cost. How does it compare in terms of cost to, the lamppost or other outdoor small cell deployments?
This is based on Swisscom's findings, but they compared it to first macro cells and then conventional small cells, like you said, on lampposts and so forth, and then the Street Connect. And they looked over a 5-year period of time to calculate all their maintenance costs, the installation of fiber and all of that, and it comes out to be about half. Mm-hmm. So it actually was very attractive from a perspective of from cost, and really that's the main driver here. Certainly they're going to use other tools as well where it makes sense. So I'm sure they're going to still continue, as any operator would, with lampposts and other types of small cells. But this really worked well from a cost perspective.
Mm-hmm. Yeah, and I guess that if fiber is available, it's easier to have it to the small cell underground than if you go to a lamppost, which is usually a problem. That getting fiber to a lamppost is very difficult.
Exactly.
Yeah. So that's interesting. I'd imagine that they must have been talking to the city, the municipalities. Are they open? Because obviously that is the street it's something that they control. So obviously you need the support of municipalities as well.
Absolutely. The right of way for locations for a Street Connect is a big deal, and zoning and placement of antennas really of any kind today. Particularly in big cities where you have this huge, dense requirement, it's a big problem. And one of the fun parts of the Street Connect is that we have cities that actually are interested in deploying this who have control of the right-of-way. So we actually have customers who will advocate and actually streamline that zoning process. So it actually gets really fun that way.
Mm-hmm. Right. And that's again, it's a whole new area because we're trying to put the telecoms infrastructure in place where traditionally there wasn't none. So are there other places? Because obviously you're not just doing this. There is way more that you're doing in terms of small cells and antennas for small cells. Where else do your products go or will go in the future?
That's really, there's a lot of tools in our toolbox, so that's an old cliche, but we have our canister products, which are relatively large, have been a favorite of neutral hosts and operators for probably 8 to 10 years already. And so that's one area, and we're enhancing those. So we're going to make those more capable. We're adding features and capability to those, extended frequency ranges as new frequencies start to come into play, which is the 3.5 and the 5.8 gigahertz. A lot of demand for that. And the other thing is that most of the small cells have been 2x2 MIMO. So traditionally that's been adequate for most capacity requirements. But we're starting to see in major cities where they really don't have any more capacity or place to put another antenna, and 4x4 is really becoming reality to get the capacity they need. So we're adding the 4x4, and the other thing that we're doing in terms of antennas, both new and existing antennas, is trying to come up with some flexible mounting, trying to make it easier to install, say on a lamppost. We have an antenna that we call a smart pipe antenna, and we internally here kind of smilingly call it the barber pole antenna because that's what it looks like. And that antenna can be mounted on, say, the corner of a building. And what's cool about it is it has the ability to rotate the direction of the antennas, and you can customize the coverage. So I can have this thing on the corner of a building, say in a downtown canyon environment, and I can aim one antenna to the north, and I can aim one antenna to the west. Another thing I can do with that antenna is I can mount it like a paper towel roll, and meaning that it's horizontal, and I can mount it on the side of a building, and I can aim one antenna at the lower floors and one antenna at the higher floors. Another mounting solution that we've had fun with is to mount it on what they call the messenger wires. So those are the strand cables that run on telephone poles. So we have a kit to mount that antenna hanging from the wire next to a radio, and we can accommodate 2x2 or 4x4 MIMO with it. And again, we can adjust where the beams go. And so those are the kinds of things we're doing with kind of the existing antennas. And then in terms of new product, we're coming out with a series of antennas that I would best liken to Lego blocks. They're antennas that are designed to be mounted in hidden places, places like behind, say, an advertising sign in an airport or some public space. And you can configure them by combining them together. So if I need more gain or more directionality, I can combine 2 or 3 or 4 of them together. I can put them back to back. So lots of good applications. So we're really having fun with the small cells.
And I guess it's a lot. You require a lot of flexibility, which is what is going to be moving forward. Operators will need it because they might get more bands, but also they have more services to support. And one of them that is going to create a lot of unusual sort of demand is IoT, because there you have different type of services, different type of devices, and use cases, revenue opportunities. So how is IoT going to impact what you do? And how can you help operators get into that market?
Good question. Boy, the IoT is kind of coming fast. It's coming faster than we maybe thought it was going to be. Things like connected car, for example. We are starting to build in the 5.9 gigahertz, for example, into antennas, so that we can participate in that connected car business when it occurs. Kathrein is a huge supplier of the automotive antennas as well, so we tie that in. We supply most of the major manufacturers in the world actually with automotive antennas, and so built into those antennas are we're already thinking about how we're going to do the connected car. And of course, with the Internet of Things, there's all these layers. Kathrein has a broadcast group, so when you have slow data applications, we may tie that into broadcast. We have satellite, we have hybrid fiber coax. So all of these things tie together, and so we're trying really to coordinate our effort in all of those things for IoT.
How do you see the broadcast part fitting into this sort of a IoT expanded usage, congestion, small cells?
I don't know the answer to that actually. I mean, it's a capability that we have. You can do broadcasting. There's subchannels, and where there's a need to say do broadcasting of information to a wide variety of users, it's going to come into play. I just know that it will be part of that overall picture at some point.
Yeah, and like I said, the broadcast it's a concept that we have been working for a long time in terms of how do we actually. I think it's exactly your answer is how can we use it given there's a lot of potential, but what's the best way to harness it? And I guess with the increase in demand, we'll have to see how that plays out.
And it also could be things like what they call LoRa, the LoRa, which is the 900 megahertz.
Yeah.
We're also seeing L-band, which, the 1500 megahertz. And so all of those frequency blocks start tying into the Internet of Things, and you start using them in the most appropriate way for whatever layer you're trying to accommodate.
Yeah. So IoT will require this additional bands. So you think that there's going to be separate bands, more specifically devoted to IoT and specific IoT, applications with IoT, say connected cars or something else? Is that the way you expect it to work out?
I just see that they all have appropriate usages. So from meter reading to we have applications where you have really low latency requirements. You're going to do one technology. Where you're reading a meter once a month, you don't care when it comes in. When you're trying to maybe do an emergency broadcast, you might have a different technology. So they all are going to be useful tools down the road. I don't really know all the answers, but
yeah. So now the availability of different bands. I personally think that the greatest impact is that the fact that you can have small cells and macro cells working on different channels, which would simplify life for everybody involved, I think. But at the same time, we still have a lot of channel deployments where macro and small cells are using the same spectrum, and interference has to be managed. What's your view on that? Because that has been for a long time a major concern for operators. How can we address that?
It is a tough question. The more frequencies you put into usage, the more of these multi-band antennas that we have, the more combinations for intermod that you have. So that's one aspect. And then again, you're trying to deal with not interfering with the macro level. Really, placement is key. Adjustable beams is key. Probably adjustable power on radios is key, so you can optimize a network that way to minimize those overlaps. So I think every situation is going to be kind of custom tuned, so to speak, trying to optimize it.
Mm-hmm. Yeah, absolutely. So, so you mentioned at the beginning that you have been working in focusing personally on the U.S. and listening to what you hear from your customers, but you're also working for a company that's based in Europe. Can you tell us a little bit about what is that you hear, and what is that you hear that is different in different geographies?
And different places in the world, really the main differences are frequency spectrum, so that's one obvious area. And there are different regulations in different countries. So in Europe, for example, the height of an antenna is much more tightly controlled. They also will tend to limit what they call the lower side lobes. So they're more concerned than we are in the U.S. about the RF exposure to people. They tend to actually have really stringent standards for that. In fact, that was an interesting part of the Street Connect, this manhole cover antenna, that Switzerland actually has the most stringent requirements for RF exposure in the world by about 10 times. Mm-hmm. And so that was actually a great proving ground for the product in terms of that RF exposure issue. that we really had to deal with. And we actually have dealt with that now. I'm kind of a little bit of a segue here on that, but we have dealt with that. We've done a lot of testing here in the U.S. We've done trials. We've got, I think, at least 10 trials going on. So we've come to the point where our exposure limits are maybe 10% of the values that we could actually reach. So we're very conservative in our RF exposure, the maximum permissible exposure, and yet we're trying to make the system work well. So we're trying to get as much power, power into, because we want to get good coverage and good performance out of it. So those are all the things that we've been really doing with our trials. So we're really figuring out how to apply these, how to prevent that exposure or interference with the macro antennas. So we're ready to move forward. Actually, we're at a point now where we've made good progress there. We're ready to actually start installing these.
Yeah. So that's exciting. But now one other thing is that with small cells, it seems like the technology is there. We're all ready to go. All the vendors are ready, and most of the time, the big challenge to roll out is it's really the operational part, installing it, getting all the permissions right away, electricity, power, and the sort of the details that are kind of like not a very sexy topic to talk about. How can you, or how do you help, and how do you see that helping in terms of reducing the complexity and getting a business model that works much more smoothly than it does today?
Yeah, good question. And I think we've gone on a couple of routes that way. One way is to partner with other vendors, vendors that might focus and specialize, say, in advertising signs, who may have already rights of way in cities, who maybe have already worked with city governments to establish agreements where they have expedited zoning permits and approvals, and in many cases where they already have power and fiber in the ground. And so that's really the biggest way that we're doing to start out with. And then you're absolutely correct. It is a time-consuming process to figure out ways to get the right-of-way, the permissions, the zoning, and so on. But again, it seems like many of the larger cities who really need this coverage are being very cooperative to us. So we actually have that in our favor.
Yeah. Well, I guess it's a win-win situation to find a model that works a little bit more a model more similar to, say, the macro model, where we know what we're getting into, so it's easier to deploy. Now, let me just, as a final question, ask you about what is that you guys are working on, say, to get ready to meet the challenge over the next years, because we've been talking about small cells for a long time, but we haven't really got the critical mass, which I think we're going to start needing now because of increased use and IoT that are driving or potentially driving demand and revenues.
It really comes back to just evolving the products that we have to add the new bands to them. I mean, there's a big demand from operators who really want to future-proof their systems. So the 3.5 and the 5.8 gigahertz, that's a big deal. Adding the 4x4 capability, particularly at the high band frequencies, big deal. Everybody wants it. They all want to be ready for it when it comes. And then adding these flexible products that allow, in many cases, really to install an antenna in a non-conventional location. Those are really the directions that we're headed with the small cells.
And I guess that this is actually a really new field, because when you look at antennas over the past, 20, 30 years, it was just a question of getting the antenna from a performance point of view better, rather than conceal it or, whatever, to put it in a different location. I guess this is like really the small cell and the need to have telecom infrastructure everywhere. So you want it to be less intrusive.
Right, and it is interestingly enough, we've done simulations. So, say for example, in Manhattan, where we've taken a series of conditions and parameters that we plug into some software, and we compare the performance of different models. So it could be an external antennas on light poles versus Street Connect versus a canister. We look at the different heights of installations, how high, and we have found that, that's a critical element. How high do you put that antenna? And so we can make evaluations then on which are the most effective tools for a given situation. And it's also interesting, really, that the performance doesn't vary that much between the Street Connect or what we call a slim pole, which is a small antenna, or the barber pole antenna, as we call it. Actually, it's encouraging how well they all work in their right place.
But you say in the right place, so does that mean that there is no best solution, but in general, but there is a best solution for a given environment? And maybe you can learn to generalize that if you know that the environment looks this way, that's probably the best way to go. Is that?
Exactly.
Excellent. Well, that's I think that's interesting because it's going to allow operators to use all the variety of tools that they have at their disposal. Okay, Jim. Well, thank you so much for sharing your thoughts with us today.
Thank you, Monica. I appreciate the chance.
And thank you all for listening in. This was a conversation for a report on densification in the RAN by Sensafil in collaboration with RCR Wireless. Thank you again.